Assalamualaikum and hi everyone. The next subtopic we're going to learn is 4.2, Newton's law of motion. So here we have two learning outcomes. First is to state Newton's laws of motion. Second is to apply Newton's law of motion. So we have three laws here. Newton's first law, Newton's second law, Newton's third law. So in this video, I'm only going to cover the first law. The second and the third law we'll be covering it in the next subtopic. Okay, let's look at the Newton's first law. So according to Newton's first law, an object that is at rest will remain at rest, or an object that is moving will continue to move in straight line with constant velocity if and only if the net force on the object is equal to 0, or the sum of the force is equal to 0. Okay, so basically, this Newton's first law, we can understand it through two concepts. Okay, first concept is the concept of inertia, and second one is the concept of equilibrium. So kita tengok the first one dahulu. Inertia is defined as the tendency of a body to resist change in motion. So inertia ni dia mesti resist change in motion. So what happen if it wants to resist change in motion? Okay, kalau tengok the first one. The first statement, an object that is at rest will remain at rest. So kalau kita ada object, maybe this is a box on the floor. So this box is at rest. We don't exert a force. Kita tidak bagi force. Kita tidak tolak dia atau tarik dia. No force at all. So what happened if there is no force? Okay, kalau tidak force, what happened to the box? It will remain at rest. Okay, we will continue to remain at rest. And then the next statement here, an object that is moving will continue to move in a straight line with constant velocity. So if we have a car, it's moving with constant velocity of 30 meter per second. Okay, this car is moving with 30 meter per second. So if there is no force, tiada force yang dikenakan kepada kereta ni, tiada external force, what happen is it will continue to move in a constant velocity. Okay, so this concept inertia comes in hand when there is a change in motion. Bila ada force yang dikenakan kepada situasi ni. Sebab dekat sini, dia punya condition adalah the net force must be 0. So kalau kita letakkan, kita exert force kepada situasi yang Miss explain tadi tu, apa yang berlaku adalah inertia dia akan resist the change in motion. So macam mana dia resist the change in motion? Okay, let's look at the video here. Okay, so this car is moving to the left. Okay, we just assume it moving with a constant velocity. And then suddenly there is something in front. Okay, kita anggap ni adalah satu force lah. Maksudnya ada force yang menghalang untuk kereta ni daripada moving in a constant velocity to the left. So apa yang berlaku apabila ada force yang menghalang kereta ni? So kamu tengok dekat sini, apabila ada force, suddenly kereta ni akan stop. Maksudnya akan ada unbalanced force dekat sini. Force dia sudah bukan sama dengan kosong. Ada unbalanced force. So apabila ada unbalanced force, what happen is, okay, the person inside the car will continue to move. Sebab inertia cakap dia kena resist the change. Apabila dia resist the change, dia still akan moving to the left. That's why, okay, badan penumpang ni, this one lah, yang dekat bawah ni adalah apabila dia pakai seatbelt. Okay, dekat atas ni, that's why badan penumpang tu dia akan ke depan. Dia akan continue to move. Okay, continue to move in front. So that's what the inertia concept is. Okay, dia akan continue to move sebab dia mau resist that change in motion. hopefully kamu faham lah the concept of inertia here. Okay, the next one is the concept for equilibrium. So the condition for this concept is the net force on the object must be equal to 0, which means if the net force is equal to 0, so the net force for x component is 0, y component is also equal to 0. So kedua-duanya mesti equal to 0 kalau ada condition equilibrium. Okay, now let's look at the simulation here. Okay, so we have 2 people on the left, 2 people on the right side here. So they are pulling the rope here. So they are pulling with the same amount of force. Okay, left force 250 Newton, right force 250 Newton. Okay, so let's see what happened. So when I push go, nothing happens. Okay, this object in the middle here is remain at rest. Why? Why? Because when we sum the forces from both sides will be equal to 0. So equal to 0 here meaning that okay, the situation here is at equilibrium. Okay, equilibrium bukan bermaksud tiada force yang dikenakan. Equilibrium bermaksud apabila kita tambah semua force yang terlibat, dia akan jadi sama dengan kosong. Kenapa akan jadi sama dengan kosong? Sebab satu, kita tahu force adalah vector quantity. If the force is to the left, meaning that we will get negative here. So negative here plus here, it will cancel out. So that's why the sum of forces is equal to 0. So maksudnya dekat sini, okay, situasi ni adalah berada dalam situasi equilibrium. So mereka balance lah dekat sini. Force yang sama daripada kanan dan kiri. Okay, so what happened if I put another person here? So when I put another person here, as you can see, the force is no longer the same on both sides. Okay, unbalanced force. So now the sum of forces is equal to 50. So I press go. As you can see, okay, the object here will be moving to the right. As you can see, we have more force on the right side compared to the left side. So now situasi dekat sini bukanlah equilibrium. Okay, so just remember, for equilibrium tidak bermaksud tiada force yang dikenakan. Dia hanya bermaksud apabila kita tambah semua force tu, dia akan jadi kosong. Okay, so basically equilibrium we have 2 types. First is static equilibrium, where the velocity is equal to 0, the object is at rest. Next one is dynamic equilibrium, when the object is moving with a constant velocity. Okay, we will look at how to solve the problem related to equilibrium in the next video. Thank you.